So hi everyone, welcome back to my channel. So for this video I attempt to show you how the constant b here could affect the original function f of x. So again I show you the original function here f of x, and I show you these two functions, and it's a new function I'm going to graph. So let's consider the first function y equals f of 2x. So the 2 here is inside the parentheses and is considered one of the b value parameter. So I hope you guys still remember from this slide I showed you in the previous lecture. So in the first question, I'm dealing with the b value equals to 2. So how the b value is equals to 2 could affect original function? So let's see. So b equals to 2 is fall into this range if b greater than 1. The horizontal portion of the function is being contracted by the factor of 1 over b. So if you remember from our previous animation, when b is greater than 1, the horizontal portion of the function of the new function is going to be contracted by this factor 1 over b. So y is 1 over b but not b. So if you write b here, it means that the horizontal component is going to be expanded by b. So it is not true. So the horizontal component is going to be smaller when the b is greater than 1. So that's why I need to use the reciprocal number of b, which is 1 over b. So which means that when b equals to 2, the horizontal portion of the function is going to be contracted by a factor of 1 over 2, and it's going to affect the x-coordinate because it's a horizontal stretch. So the x-coordinate, I need to multiply every x-coordinate by 1 over 2 for the first question. So what is b equals to 2 tells us? So it tells us two things. It tells us that the horizontal component of this original function will going to be affected. So when b equals to 2, we know that the horizontal component of the original function will be contracted by 1 over 2 because it will be smaller. So I need to times a fraction 1 over 2, the reciprocal to the b value. So if I times all x values by 1 over 2, I will get the first value -4, -3 over 2, 3 over 2, and 4. So next I'm using these two columns. The left handmost column is a new x-coordinate for the first question, and the right handmost column is a new y-coordinate for the first question. And I'm going to plot these 2 points and I generate the graph for the first question. So let's see. So the first point we have -4 and -3. So around at this position, -4 and -3, right? So the second point, -3 over 2 and -3 is around at this point. 3 over 2 and 3 is around at this point right here. And 4, 3 is around at this point. And I'm going to connect this point here, and I should generate something like this. The blue curve here is the new function, y equals f of 2x. So basically, if you notice that this blue function will overlap some portion of the red function, but it's fine. So instead, I show that the horizontal component is contracted, then you are correct for this question. So next, I'm going to move on to question 2. So question 2 asks me to graph y equals f of -4x. So at this time, the b value is -4. So how the b value equals to -4 affect original function in the red curve? So let's see. So b equals to -4 actually fall into this range, b less than -1. So when b is less than -1, you know that the function is going to be reflected in y-axis, then the function is going to be contracted in horizontal direction by 1 over b. So this is what we notice. So b equals to -4 tells me that the horizontal component of this original function is going to be contracted by the factor 1 over 4. So I need to times every x value by 1 over 4, and the y value remains the same. So no change for y values. So notice that we have the negative here. So basically I need to keep the negative when I multiply every x value because this negative implies that I need to reflect all these points in y-axis. So that's why I need to put the negative here. So basically I just need to times every x value by -1 over 4 to get this number equals to 2, 3 over 4, -3 over 4, and -2. So basically I'm using this column and this column here to generate the graph for the question 2. So the first point we have is 2, -3. So 2, -3 is around this position, 2, -3. And also 3/4, -3 is around this position, right? So -3/4 and 3 around this position. So -2 and 3 is around this position. So I'm going to connect these 2 points together, and you should get something like this. So this green curve showing you the y equals f of -4x. So you notice that this function is going to be reflected in y-axis, and it's going to be contracted in horizontal direction.